Alright kiddos, welcome back. We're going to continue writing names and formulas for ionic compounds. We're going to start with example 4. I know we just finished that example at the end of the last video, but I know a few of you were a little bit hazy on the use of Roman numerals, so I thought I would do that one over for you. Okay? Alright, now if we look at the periodic table, you might remember that all metals in group 1 are always positive 1 and never anything else. All elements in group 2, their oxidation number is +2 and never anything else. The noble gases don't form bonds, so they have an oxidation number of 0. The halogens, group 17, these guys are -1 and never anything else. The nonmetals in group 16, headed up by oxygen, these are all -2 when they form ionic bonds. The nonmetals in group 15, nitrogen and phosphorus, will be -3 when forming ionic bonds. And then some of the other metals in the middle of our periodic table, remember aluminum is always +3, zinc is always +2, so is cadmium, and silver is always +1. Now all other metals, kiddos, so all of these metals here on the periodic table and down here can have more than one oxidation number. They can have more than one positive charge. So we need to tell the reader, when we write the name for an ionic compound, the positive charge of the metal that we were using, and we do that by using Roman numerals. So let me go back to example 4 for you folks. We have copper and sulfur that we're using. Okay, now copper is right over here on the periodic table. So it's one of those metals whose positive charge we don't know. Turns out copper can be +1 or +2. Sulfur is over here. Now that's easy. That's a nonmetal. You can see that it's -2, but we could figure out another way. It has 16 electrons. It wants to get to 18, so it's going to gain 2, and it would have an oxidation number of -2. So sulfur is -2. Copper, it's a little bit of a mystery. We don't know the positive charge for sure of copper yet, because it could be +1 or +2. But it's pretty easily figured out. Notice that sulfur is -2, and there's only one sulfur atom in that compound. Well, the sum of the charge has to equal 0. So if sulfur is -2, what does this copper have to be so the sum of the charge equals 0? That's right. If you said +2, you would be correct. So now we have a copper that's +2 and a sulfur that's -2, and the sum of the charge is equal to 0. So now we can write the name of this compound. We start by writing the name of the metal, copper, and then we're going to put a Roman numeral in here in just a minute telling us the oxidation number of copper. And then we're going to end the name of the compound with the nonmetal, but we're going to change its ending to "ide." So instead of saying sulfuride, we'd like to say sulfide. So it's copper something sulfide. Now remember, the Roman numeral, folks, is the charge of the metal as a Roman numeral. So we're going to put the Roman numeral 2 in here. So this compound is called copper 2 sulfide. Notice, please, there's only one copper atom. And there's only one sulfur atom. The reason it's called copper 2 is because of the oxidation number of copper. It's +2. That's what the Roman numeral tells us. Alright, let's see if you can do one on your own. Why don't you try example number 5 without my help? Remember, you may or may not need to use a Roman numeral for example 5. So pause the video, try number 5, and come back and see how you did. Alright, welcome back. Let's find strontium and selenium on the periodic table. Strontium, folks, is over here on the table. Looks like it's always going to be +2. I don't need a Roman numeral for strontium, do I? Selenium's over here. It has 34 electrons. Wants to get to 36, so it's -2. So this one's not too hard at all. Strontium is always +2. Selenium is -2. We don't need Roman numerals for this, so we're just going to name the metal strontium. And then we'll name the nonmetal, but we'll change its ending to "ide." So instead of saying seleniumide, we like to say selenide. So if you wrote strontium selenide, for example, number 5, good job. Many of you, I'll bet, used Roman numerals, but remember, if the metal's in group 1 or 2, or if it's aluminum, zinc, cadmium, or silver, you do not need Roman numerals for those metals. Okay? So let's go ahead and write that down in our notes. When are Roman numerals required in a name? So it's when the metal is not in group 1 or 2. Are there any other exceptions to that? Yeah. Silver is an exception. It's always positive 1. Zinc is an exception. It's always positive 2. Cadmium's always positive 2. And aluminum is always positive 3. All other metals will need Roman numerals in their name. Okay? All right. The first section on the top of the next page goes over what I just told you, so we'll go through it again very quickly for you. Number 1, all elements except hydrogen in group 1 will have a charge of positive 1 and never anything else. Group 2, they have a charge of positive 2 and never anything else. Group 17, that should say 17 kiddos, not 7. Those are the halogens, are negative 1 and never anything else. Group 16, that should say 16 kiddos, have a charge of negative 2 and never anything else. All other metals have more than one charge, and that charge needs to be given in the name of the compound by using Roman numerals. There are 3 metals in this category that are exceptions. Aluminum is always positive 3. Zinc and cadmium are always positive 2. So I guess we should say there are 4 metals that are exceptions to that. Silver is always positive 1. All right. Don't worry, we're going to do more examples. If you're a little bit confused, we'll try to straighten that out before you have to do your first assignment, okay? All right, let's talk about something called polyatomic ions or radicals. Polyatomic ions or radicals are ions made of more than one atom. If you remember, when we drew Lewis structures, we drew Lewis structures for polyatomic ions. You might remember a few of them. It's okay if you don't. I'm going to show you where to find a big list of them in your manual. So now we have ions made up of more than one atom. Now, on the back of your periodic table on page 2 of your manual is a list of radicals that you will need to know for this class. Let me just show it to you quickly. If you go to the back of your periodic table, you'll see a list of polyatomic ions. I give you their formula, their charge, and of course their name. Now we do not change the ending of polyatomic ions. We don't change them. You'll notice that almost all of them end with 8, or you'll see a bunch that end with "ite." And of course there are a few others, but most of them end with 8 or "ite." Okay, so this list, once again, is at the front of your manual, right behind your periodic table. So if I were to ask you to write the formula for this compound, chromium 3 nitrite, we should be able to do that. Chromium is a metal, and it happens to be positive 3. You might say to yourself, well, how do you know, Hummer, that chromium is positive 3? It's right there on the periodic table. I thought you said that can have more than one charge. I thought you said we don't know the positive charge of that metal. Well, let's take a look at the name again. Doesn't it say chromium, Roman numeral 3? That tells me that it's positive 3. Nitrite. Hey, that ends with "ite." Didn't we just talk about a bunch of polyatomic ions that end with "ite" or 8? Let's see if we can find nitrite on your polyatomic ion list. Let's clear this page so it's a bit easier to see. Scroll down, see if we can, oh, here we go, nitrite. It looks like its formula is NO2 with a -1 charge. Let's write that down. NO2 with a -1 charge. Chromium's +3. Each nitrite is -1, so it seems to me like I would need 3 nitrites to balance out the charge of the +3 from chromium. So how would we write that formula? Well, let's write the metal down first, chromium, and I need 3 of these nitrites. So what I do is I put parentheses around the formula for the polyatomic ion, and then I write the number as a subscript next to it as to how many I need. And that would be the formula of chromium 3 nitrite. Notice there's no charge in the formula. There's no positive or negatives left in this formula. They've been canceled out. The +3 has been canceled out by these negative charges of my nitrites. Okay? Alright, let's do another one for you. ReSO42. I'm going to go ahead and I want to name that compound, ReSO42. So let's go to the periodic table. This is getting a bit claustrophobic. Let's clear the page and let's find rhenium. So do you guys see rhenium right there? So once again, its charge is going to be a mystery for a minute. So let's see what it's bonded to. Looks like it's bonded to 2 SO4s. So let's see what SO4 is on our polyatomic chart. SO4, here we go. SO4, it's called sulfate, and each one has a -2 charge. Okay, so each one of those is -2. Looks like there are 2 of them, right? So I'm going to write down 2 of them here. I have a -2 and another -2. That adds up to -4, doesn't it? So what does the charge of rhenium have to be? Well, if I have -2 and -2 for a total of -4, doesn't rhenium have to be +4? It does. So then, if I have 1 rhenium, which is what I have, and 2 sulfates, which is what I have, the sum of the charge would add up to 0. So the name of that compound is rhenium, and rhenium is RHENIUM. We're going to leave parentheses there. We're going to leave that blank for just a minute, and then we're going to end it with sulfate. Remember, we don't change the ending of polyatomic ions. Now what goes in that parentheses? Let's change our color here just for fun. That's right, it's the charge of the metal ion written as a Roman numeral. So I want to write the Roman numeral 4 in there, which is IV. So the name of that compound is rhenium, Roman numeral 4, sulfate. Okay, let's do a few more. Silver permanganate. Silver. Now silver is one of those that I always know the charge of. Isn't silver always going to be +1? Remember, it's one of the exceptions. Permanganate. It's one of those that ends with 8 or 8. I'll bet that's a polyatomic ion. Let's see. Oh, here's permanganate right there. Its formula is MnO4 and its charge is -1. So let's see. MnO4 -1. How many of each of those do we need so that the sum of the charge equals 0? See, +1 and -1. I think just one of each. So I write down silver, I only need one of those, and I write down the formula for the polyatomic ion permanganate, MnO4, and I only need one of those. So that is the formula for silver permanganate. Notice there's no charge in my formula. All the positives and negatives have canceled out. Okay, let's end this video with example 9. Why don't you try doing example 9 without my help? So pause the video now, and then come back in just a minute after you're done. We'll see how you did. Okay, welcome back. We have cobalt, and then this polyatomic ion, OH. Looks like there are 2 of them. So cobalt, CO. CO is right here on the periodic table. It's another one of those whose charge we don't know. Okay, so cobalt CO, and we're going to put a question mark here for its charge. We don't know it right now. OH, that's a polyatomic ion. See how it's made up of more than one atom? So let's go ahead and find OH on this chart. Oh, here it is, OH. It's -1, and it's called hydroxide. So OH is -1. Looks like there are two OHs, right? So I'm going to write it down twice. So I have -1 and -1. Does that equal -2? Yeah. So what does the charge of this cobalt have to be? That's right. There's only one of them. So if you said +2, you are correct. So the name of this compound, we're going to name the metal first, is cobalt. We need Roman numerals for it. And we're going to say hydroxide. Remember, because OH negative is the polyatomic ion hydroxide. So we have cobalt. We're going to put a Roman numeral there in a minute, hydroxide. So what Roman numeral are we going to put there? Remember, the Roman numeral has to be the charge of the metal written as a Roman numeral. So the charge of the metal is 2, so I'm going to write the Roman numeral 2 there. So that's cobalt 2 hydroxide. Okay? All right, once again, if you're a little confused, that's okay. Trust me, we have a bunch more examples for you coming up. So we'll talk to you soon. Bye-bye.